Welcome, everyone. Thank you for taking some time out of your day to join us for another webinar. I recognize a lot of the names on the RSVP list, so those of you that have been to our webinars in the past, thanks for joining us again. Those that haven't joined us, I'm Brian Greger. I'm the president of Aldridge. We're an IT outsourcing company based in Texas with an office also in Seattle, Washington, so we've got some folks up that way as well. Wanted to get together with everyone today to bring a new topic that we haven't talked about in our webinar series, and that topic's all around AI. And so there's a lot of buzz in the media about this and a lot of confusion as to what's right for me in business versus can my kid use it to write their term paper to God knows what else. So wanted to just kind of get together, have a discussion about it today. I'm a member of a peer group called True Profits Group. It's a bunch of IT providers like us. We get together once a quarter. And at one of our recent meetings, we got to meet the folks that are with us today from NLP Logix. And they came presented on a project they were doing for another IT provider. And it was fascinating to me personally. And so I wanted to get an opportunity for them to talk with you all today. And we've also got Chad Hiatt, our CIO, with us today to give some information from our perspective. So just a couple of housekeeping items. We do have the Q&A box up there for you, or the chat, whichever one. If you have some questions that you want us to make sure that we answer, feel free to give those to us. We'll make sure that either I'll sprinkle them in throughout the presentation or work those in towards the end. If for some reason we get so many questions that we don't have time to get through, I'll make sure that you get a written response back to that. So with that, I'll shut up so that you guys can hear from the people that you actually came to hear from. And so I'll start by introducing our guests from NLP Logix, Katie Bakewell and Ted Willich. And so Katie, let me kind of turn it over to you, do a little introduction, Ted as well, and then we'll kick it over to Chad to dive in.
All right, so I'm Katie Bakewell. I am a data science solutions architect at NLP Logix. I've been here for just about 10 years building AI solutions in just about every industry I can count. I'm really excited. Thank you so much for having us here today. And I will kick it over to Ted.
Yeah. And I'm Ted Willich, co-founder and CEO of NLP Logix. NLP Logix is based in Jacksonville, Florida, and we are a AI/machine learning solutions consultancy, which means we go in and we solve specific business problems using the AI technology stack that Chad and Katie are going to talk to us about. A little bit about NLP Logix. We've been in business 12 years, and I can assure you the first couple of years when we were trying to explain what machine learning was, this is before anyone started calling it AI, it was a really difficult pitch. We had to do a lot of consulting and educating and everything, but now in the last 4 or 5 years, and certainly the last year or two, there's been a lot of acceleration in the field and has created a lot of buzz. Our company, we have about 90 team members, including an office in the Philippines as well as in Serbia, because a lot of the solutions that we provide, we have to chase the sun and we have to provide support, because a lot of the machine learning applications that we do automate customers' business, and when the machines break, you got to have a human to jump on there and fix them. And yeah, again, can't thank you guys enough for inviting us, Brian and Chad. Thank you, and we look forward to answering any questions we can. And I'll kick it over to Chad. Chad, you're up.
Cool. Oh, I'm Chad Hiatt. I see a number of familiar names on the list, so thanks everybody for joining us. Katie, Ted, thanks for the intro to what NLP does. One of the most exciting things that I get to do as the CIO of Aldridge is help our clients understand what their business objectives are, and then what technology we can bring to the table to help them achieve those business objectives. And AI has become a very big topic across a large number of clients, and so we're connecting our clients with people like NLP Logix to say, while Aldridge can make your infrastructure work great, can make your cloud services work great, and so forth, to achieve that specific business objective, we really want to bring in a subject matter expert that's going to help take that to the next level, because that's what it's going to take to make it successful. So with that, let me go ahead and jump into our presentation and start walking through how to think about AI from a business perspective, but then Katie is going to walk us through some very specific examples that she's done of cases where they've deployed AI, what they tried to accomplish, what the outputs were, and then we'll wrap up with questions towards the end. When we start talking about AI, I'm going to use as this big umbrella term, and you'll hear these other terms like machine learning and deep learning, and there's a couple of other fun acronyms we'll throw around a little bit later on here too. The goal is not to show how all these acronyms interconnect, but that this is all part of one field. More specifically, AI today is not sentient supercomputers. AI is not yet something that you'd mistake for a person in a general sense. Those are still in the realm of sci-fi, and that's subspace communication, warp drives and transporters and so on. But AI overall is this idea that you don't necessarily have to create the algorithm by hand. You create the parameters for the algorithm and then rapidly throw in information to the system and then judge the output of the system. And there's variations on that. Like machine learning, for example, takes large input sets and known output sets, and in most cases, and there's subdisciplines that don't require that, but you then teach it by saying, with these inputs, I got these outputs, and these are right and these are wrong. Now, I'm going to give you new inputs. Are those inputs going to give me a good output or a bad output? At the most basic level. There's another tier below that, deep learning, which is a subset of this, where you're not having to necessarily tell it what's right and wrong. The machine is competitively understanding that's closer, that's farther away from the goal of what we're trying to get to. And so in both of these cases, in all of these cases, the whole field of AI is the stuff inside the box is not something that a person has to manually write. Person still has to tune the output, tune the loop, understand that you're feeding it good information in so you can get good information out. But a lot of the actual programming, and using the older term for it, that programming is being done by the AI algorithm itself, not connecting the individual inputs to the individual outputs, kind of like we do with an Excel spreadsheet. More broadly, a lot of people are asking the question, is AI going to drive change? And yeah, yes, AI will drive change, and AI will drive displacement. I mean, it has, and it will continue to change how we work with information, how we handle repetitive or derivative tasks, and it will change the business relevance of particular skills, and it will change expectations for responsiveness and for quality and for engagement. But AI is not unique in those ways, and one of the things that you have to work with your teams is helping them understand AI is not scary, it's just a different way of doing things. You've already been through these types of tool set evolutions, and they do drive these types of changes and displacements. Imagine if all the math that you work with today, or that we all work with in the world, was still done on chalkboards or with pen and paper, and it was all done longhand. It worked, but it wasn't very efficient. There were faster ways to do it. So we get things like the slide rule, and there's efficiency improvements, there's new algorithms, there's better techniques, and our capacity to process information and complex problems improves along with the tools. Longhand math was, and it's still relevant. You can go back to it. You can check the work of other processes. You have to understand the working theories, but then you have to be able to peer inside the box. But the cost of entry for complex math started to come down. With further advancement, those algorithms get bottled up into a convenient user interface. And while it's still possible to apply the manual effort, you still have to give it good inputs to be able to interpret and know that you're getting good outputs. It takes significantly less time. There's less cost, there's less effort, and all of that's continuing to drop until you get close to where the cost of doing complex math is approaching zero for most applications. The field is becoming more and more accessible. I can still remember when Microsoft Excel skills were something worthwhile to put on a resume, and we're probably not anymore today. We all operate really complex mathematical models to varying degrees of effectiveness, but with very little effort or additional specialized training. The value of the skills of complex math, number models, and so forth, it's shifted to being able to frame, interpret, and successfully apply the results of the process in a meaningful way. The inner workings of a trusted process model, all the thousands or millions of calculations, they're now trivial and they're near zero nominal cost, and AI is progressing the same way. And kudos, another example, if you recognize a snip from some of the books from Thomas Jefferson's personal library. This is a photo from the books that are on display at the Library of Congress. That was a way knowledge was organized and it was maintained, but it was slow and it was expensive to maintain and retrieve. So groups stepped in and started to pre-organize the information. And while it may not have the complete depth on any given subject, encyclopedias took thousands of topics and made them accessible and much more economical. You're now able to leverage all the work effort that's gone into compressing that knowledge and making it accessible, and the barrier to entry goes down. Well, you take it a step further. Well, anyone here still recognize Alta Vista? It was one of the first World Wide Web search engines back when it was still called the World Wide Web and not just called the internet. It started to organize the information that was being published electronically and make it accessible across sites and publishers. It was faster, it could prioritize results, and its value continued to increase exponentially as the depth of data it had available to index continued to grow. The older search engines are rarely thought of today because along came a company that had a better algorithm for relevant information search and retrieval. And the concept that the utility value of information was directly proportional to the number of quality sources that it references and that reference it. That's the Google engine's core. And it's been refinement and performance improvement since then. But imagine how readily you can now access information today on so many topics versus back in the day when you had to build and maintain a personal library just to access a fraction of that knowledge. Now, granted, I still like physical books, but I guarantee you I use Google many more times a day for knowledge retrieval. My point is, you're already using AI. Your teams are already using AI, and it's caused change, and it's caused disruption, and it's caused a reevaluation of skill sets, and that's all okay. It's a tool set. In commercial applications, there's really three types of AI that are getting particular attention and first choice considerations as you start your own AI journey. I want to get you thinking about these. Then we'll talk about the fundamentals of what a successful AI initiative looks like. And then how do you choose from the world of possibilities and prioritize your own candidate initiatives and efforts. The first one here, natural language processing, which you'll sometimes refer to as NLP. Everybody loves their acronyms. Natural language processing uses large language models, LLMs. ChatGPT is an example of natural language processing. What you're doing here is these are AI algorithms that are built more than just on keyword matches and frequency. Natural language processing establishes patterns and inferences and relationships between a very large sample of languages. Imagine a cloud-based processing engine trained on every public domain book, periodical, internet content, and more. And you can leverage those types of tools to business topics or to things specific to your industry, or you can marry them up, public data and private data, to get outputs that are unique to you. Predictive modeling is designed for quantifiable information. With a large or reasonably large sample set of inputs with loose or unknown direct associations between the inputs and the corresponding outputs that those inputs produced, predictive models can take new inputs and predict what the outputs would be. Now, cognitively, people can be challenged when the number of inputs increases beyond a handful. Patterns can be hard to discern. Predictive modeling can digest many dimensions to identify patterns in association, weighting, and inference. The last of these three that are in the short list for opportunities for some of your first AI initiatives would be computer vision. And that applies many of these same concepts, but to visual data. Pictures and video, pictures of documents, scenes of objects, live video feeds of a building interior or an area with people. Now, pre-trained from an appropriate sample size, you can leverage pre-built models to identify the number of people present, the objects present, activity indicators, pick out specific context and more. Within your own organization, it's important if you understand you already have the fundamentals down in your business, the things even before your AI first steps, such that an AI initiative is something that you'd be prepared to undertake. There's a level of maturity that you have to achieve so that you know that you're going to feed it good information and you're going to be able to get good output and you're going to be able to do something with it. So we're going to break it down into three pieces. Do you have a good source of truth? Do you have realistic goals? And do you have management maturity? AI doesn't work in a vacuum. So, well, it's not entirely true. There are autonomous vacuum cleaners that use AI. I mean, there's And AI needs training and input to give you meaningful output. And meaningful input often comes from two sources, and you probably have some of these sources in your business already today. There's structured data, things like tables. Your accounting system is structured data. Your transaction processing system, your client service information, that's structured data. And then you've got semi-structured data. You've got documents that might be spread across a file share or SharePoint or something similar to that. You've got your email, which is structured in that you can tell who, what, and when, but you've also got the content inside the email. If you're, think on this. So you can also use public sources and models for this that don't contain information specific to your business and proprietary knowledge. And you can marry that then with the internal knowledge specific to your organizations. Most organizations then take the next step and they want AI to be able to identify problems or watch indicators or process streams or predict outcomes with data specific and private to the organization. And for that step to succeed, you have to think through, what are the information assets that you have within the business today? Could a person looking at the information that you have answer the question that you're trying to ask? And if they would throw up their hands and say the information doesn't exist, well, maybe that's the first step on your AI journey, is to say, how do we incorporate those valid information feeds into our regular daily processing so we gain business value from them? But now that type of structured and unstructured information can become a source for BI reporting processes inside your organization, better management processes within your organization, and eventually AI processes within your organization. AI initiatives work best when they start with a realistic objective. And as an example, the question at the bottom is probably not the right first realistic objective for an AI initiative. It's a great question, but an AI without the appropriate inputs is probably going to give you a very generic answer on it. Nothing better than what a bunch of business books are going to probably advise you to do the same thing. As you go through brainstorming, you'll be looking for the frequent repetitive tasks that you and your teams are having to do, or the frequent patterns that you have to monitor today. Your first AI wins are going to be small. They're likely leveraging public models inside commodity products as extensions to the software tools that you're already using. You don't have to do a lot of custom development. For example, Microsoft's about to launch Microsoft Copilot. It's an AI tool that'll probably be priced about $35 per user per month, but it lets you leverage all of Microsoft's AI engineering expertise, back-end work, along with all the private information that you have secure in your Microsoft 365 tenant, your email, your Teams chats, your SharePoint, your OneDrive. You already trust Microsoft to maintain that structured and semi-structured data in a secure, private, authenticated way. Copilot now opens up one piece of that so that you, running Copilot, licensed for it, can now leverage that semi-structured and structured data, again, securely within your organization. Microsoft is built around the idea about layers of security and siloing it to make sure that it's private and protected. You can now run Copilot in that same space, but you don't have to pay for custom development. It makes for a very low entry cost to a very rich engine that already has visibility to the things that are specific to your business. Next, you want to look to your big information vendors, your accounting system, your CRM, your documents platform, your contracts platform, your AR AP platform. What are your vendors, your software vendors, already incorporating into their existing products that you use? And while the information those systems can act upon will likely be silos themselves, your accounting system is only going to know about things inside your accounting world. Your development cost, again, is going to be very low, and you'll gain the new features as your software developers that you're already working with are spending the effort to design and release them. And lastly, that third prerequisite is take a look at your own operational maturity. Do you already operate via key performance indicators or scorecards? Can you measure the transactional inputs, outputs, and success of your existing operations, your departments, and your working teams? I mean, if you invest time to put an AI system in place with the goal of improvement or efficiency, will you be able to measure the result? If you, and I'm going to say I straight out stole this thought from Katie because I think it's brilliant, but if you spend the effort to put the perfect AI system in place and it produces perfect output, do you know what you're going to do with the output? How will you be able to act on it? That's what then merits the investment along the way of getting to the system to be able to give you that answer or that process or that control that you can then actually monetize. So let's start brainstorming ideas for your organization. Let's take there's 4 areas where tools are available today to varying degrees of maturity, but the feasible, and they have feasible entry costs for most organizations. What repetitive or time-consuming tasks are you doing today in your own organizations that have clear right and wrong or desired answers? And what sets of information do you already have today, but that are difficult to correlate or monitor in a realistic amount of time into useful and actionable output? So do a brainstorming exercise with your team. Visit your managers, visit your teams, understand your workflows and your processes. What are the information tools you're using today? What vendors already have data in their systems that you already subscribe to? We use bill.com, for example, for some of our AR or for our AP and for our expense tracking. They already have that information. As they start to add AI features, we can just leverage those. Now you've got a starting list. So how do you decide what's worth attention first? I mean, out of the universe of possibilities, what's your first AI project? So quantify your ideas. And for AI candidates, things that require less personal expertise are better than things that require extensive personal expertise. And things that you have to do many times over throughout the day or week or month are better candidates than things that happen infrequently. So plot out your brainstormed ideas. And now we've got our brainstormed ideas plotted out by expertise required, lower is better, and task volume, higher is more attractive for choosing your candidate projects. So presuming you've already met the fundamentals, you know you have the information available, you expect your goal is realistic, and you know how to measure the success of your output and your system result, well, now you've got ideas that require both low personal expertise and a high volume. That's your upper right quadrant. Those are your best candidates. So let's focus in there to just that top right quadrant. And we're looking for your best candidate initial AI project. So let's take that top right quadrant in a new way. We'll expand it out. We're going to add 2 more dimensions to it. Now we're trying to estimate the cost to implement, low cost is better, and the business value of the initiative, high value is better. So we end up with new quadrants and we plot the best ideas from the last exercise on it. Let's assume we had 5 candidate ideas that made that first round cut. Considered by expected cost to implement and business value, now those ideas start to look like this. And now, from brainstorming, we want to quantify how valuable those we want to get from brainstorming to quantifying how valuable the candidate ideas are to then filtering by cost and value. And you've now got 1 or 2 top candidates for your first steps into AI for your organization. And really, I'm sure you're all saying, well, this is the same process we use for quantifying any set of initiatives within your businesses. Whether it's AI or otherwise, it's all about prioritization and expected outcomes, which is an important fact in that AI, like any other initiative, is going to take leadership and investment. You've got to get it off the ground. You've got to think of the idea, get it off the ground, feed it input, test it, verify it, make sure that it's working. But even once it's working, there's a maintenance cost. It's going to need improvements along the way. It'll need refinements along the way. It needs a leader. It needs an owner within your organization, and it needs buy-in from your team in order for it to be successful to the extent of the breadth of whatever that initiative is. And because they take effort and they have cost, you have to consider the priority of the initiatives in the context of every other business initiative that would realistically take any of your team's time and attention. It's the same as any other business initiatives. Now, granted, AI's advantage, properly applied, is its force multiplier effect. You've got efficiency and time savings and changing the way you work in many small ways until it's hard to imagine putting Excel away and going back to the chalkboard and longhand math. And with your fundamentals in place and some brainstorming with your team and some efforts to prioritize, you're now faced with, great, how do we get this done? Well, there's really 3 options, and Katie's going to speak to these a lot better than I will, but just at a high level, you can build it, you can buy it and customize it, or you can use it completely off the shelf. Off the shelf is least expensive, but it's going to be the least customized and least specific to your business. It's probably not going to know your specific information or your specific vocabulary, but the cost to entry is very, very low. That's the Microsoft Copilots of the world as an example. That's the AI features being added into the software that you're already using today. Buying and customization is where most businesses go next. There's no point in building a complete computer vision system or your own large language model from scratch when you can subscribe to existing services and models and engines that have the fundamentals covered, and then you season it securely for your own use, from your own information, with your own processes and your nuance. Within Aldridge, for example, we had to teach our service agent that when one of our employees uses the word "our," we're referring to Aldridge, the organization, and all of our knowledge in all of our systems. We had to teach it our org chart so that information authored by certain roles had higher relevance and weighting. The third option, building it, that's the most expensive option. And it's appropriate for truly custom cases, but you don't have to invent AI. There are engines and computer program libraries to use as a starting point, even if maybe there's not a strong data set to use as a starting point. You will spend more time in design and development, but the result will incrementally improve in the future to the extent that you continue to invest in its further development. So with all that preface aside, let's take all this and let's make it practical. And for that, I'm going to turn this over to one of the true experts. I'll introduce Katie again to NLP Logix, and she's going to walk us through some actual examples of implementations that they've done for various organizations. Katie, all yours.
All right, so today we're going to jump through 3 specific case studies, starting out with something that was truly one of those build it's. It's something where there wasn't really an off-the-shelf tool that they were able to use. We'll jump into something that's a little bit of a combination of that buy and customize, and then talk through something that is really, an off-the-shelf option was the best option for us to implement. So we'll start out with that build it option. So we have a fitness company that we were working with, and they had a problem where their instructors were leaving. So they want to understand, when we have instructors that are leaving, why are they leaving? What's causing them to leave? And then what could we do to help mitigate this? So the solution that we ended up looking at here is, can we build a machine learning model that can identify the likelihood that a customer would churn? So we want to identify when is an instructor going to leave, but then also be able to provide some insight. So that's one of the things with AI to help this be sort of adoptable for their team. It couldn't just be a black box where we said, instructor ABC is going to leave. We had to give them some additional insight to say, these are the conditions that are likely provoking that to happen, so they could do something and take action. So the prerequisites here is sort of, an understanding of where the customer was at when we started. This is a group, they're pretty sophisticated. They had all their data in a database. They had the ability for us to leverage external data so we could take in information about the community that the person was living in. But they had a data analyst, a DBA, they were a very good data team, but they didn't have anybody who could leverage machine learning. So they were a team that was prepared and they wanted to take on machine learning. So we wanted to go ahead and find out what is the way that we can reduce these instances of churn. We wanted to find the early indicators. So early indicators are really important, because if I've got somebody who's going to churn tomorrow, it's a lot harder to deal with than if I know somebody's, a couple months away from being at a point where there's a struggle. So they want to be able to take preventative action. So if we jump into the how, this was a custom build. There isn't really a software out there that can say, based on how many downloads of songs and how many trainings somebody's taken and when's the last time they bought a t-shirt, that can say what's the likelihood they're going to churn. They really don't have the ability to go out and get something off the shelf, but they do have that data going back years. So they have years of data where they're able to look and see, these are instructors that were working with us and then they left, and this was the behavior leading up to that. So we were looking at their web traffic, how many times they were downloading the song information or the trainings, how were they paying, did they change their payment method, and then that shopping behavior in combination with some external data from the census to pull in about their community. And the initial model here was built over the course of about 2 months. So it took, it's definitely an iterative process where we were going back and forth and saying, here's what the model's seeing, we can tweak something, we can add a new variable. So we built the initial model over the course of about 2 months. We performed background testing for a month where we see people actually going out and churning, and would we have predicted that? So they have a good understanding and a trust of the system as it goes into place. And then we started making monthly predictions. So those, once we went into support, we were able to make monthly predictions for them so they'd be able to understand at the beginning of the month. Go for it. So what we're looking at here is, we were able to sort of group everybody into 4 types of groups. So we have the active annies. Those are the people that are super, super into the system. They are really, really unlikely to churn based on their behavior. They're super engaged and they've been around for a while. We also have people that are, relatively new to the system, but they're engaged. They're on the higher side of engagement, but they do have a little bit of a higher likelihood of churn. The actual lowest group to churn isn't the most engaged, which is surprising. You'd think when you're looking at this, the person who's buying a t-shirt every month, they're the least likely to leave. But these teaching terrors, the people who are really focused on that instructor behavior, they have that lowest likelihood of churn. And then the sleeping Sallies, people who, they were older participants who were no longer participating. Those are the ones where they were really at risk. So if we look at some lessons learned, I think the big thing is to start out with a why, and then sort of Chad highlighted this earlier. It's really important to think when you're looking at these projects, what would you do if this model was perfect? If this model could say 100% of the time, what's the likelihood that somebody's going to leave? Then would you actually be able to take action on it? Because if we look at the likelihood that somebody's going to churn based on their web behavior, if they go to the cancellation page, they're really likely to churn, but you're not going to be able to do anything with that prediction. So it was working with their business team to understand what's the point where they can still have that interaction that can save this customer. We had to understand if we could make a model that was perfect, would they be able to do something with that? And then the other piece is to track model health. Things change over time. If you're looking at things, especially with, economic indicators and situations like that, we want to understand, are we seeing changes, and are those changing the outcomes? So it's something where you can't just put a model into production and say, great, it's there, it exists, we never have to look at it again, it's just solving all of our problems. We want to have something where we're going and we're continuing to make sure that the model's performing the way we expect, that the data's not done anything funky. You can always retrain these models without that initial cost again. So you can go through a short process to retrain, but making sure that that's happening day on day is really important. So we'll jump into case 2, which is Google reviews. So this was something where we were working with a credit union who wanted to understand their social media presence and the topics that are highlighted. And I think most people that work in marketing are doing this, where you have to go in and you have to look at what people are saying in your reviews, and you're doing it, day by day. If you've got, I've left Google reviews and like 10 minutes later, the business owner responded like, hey, thanks for the positive review. I know people are looking at this on a daily basis. But they wanted to understand, what are people saying? They don't, they have too many branches to really have somebody whose full-time job is to check each of the branches and then, all right, let's go back to page 1 and start again. So they wanted to understand their reviews and how are they comparing to other institutions. So they have a small group of technical people. They have one data analyst position in the credit union that we're working with. So they do have people that are technical, and they did have a really strong marketing team that was able to provide us a lot of insight here. And the data wasn't necessarily available to the organization in a friendly way. They're able to go and see Google reviews, but we were able to work with a group to help them get that information. And again, that current process is really just a manual thing. So we went through and, we wanted to say, why would you want to do this in the first place? And member satisfaction is huge. It's integral to an organization that your members are happy. Especially when you're looking at credit unions versus, other financial institutions, it's a membership-based thing. So understanding not only are people happy, but what are the things they're happy about and what are the things they're not happy about in an automated fashion is going to be really important. So the process that we went through to do this was a combination of a custom build on top of an out-of-the-box solution. So when you're looking at is somebody happy, yes or no, based on text? Sentiment modeling is something where there are outstanding models. And I think You can evaluate them if there's really, really specific use cases for yourself. You might want something that's trained specifically on your data, but a lot of the time, there's out-of-the-box sentiment models that do a really good job. But on top of that, they wanted to understand the topics. And there's not really something that goes out there and says, what are the specific topics in banking? So, we wanted to put those two things together. And the model, because we were able to leverage that out-of-the-box solution for the sentiment part of this, we're actually able to build this model over the course of about a month. And then we have to go through iteratively with the team and add new information. So when we look at this, if we're looking at a selected institution, we can look at one of the banks that was, in our local area as the example that we started with. But we can go and say, based on this, let's look at the reviews that we're getting. They have a higher average rating or a lower average rating than what is seen at other institutions. How many times are we seeing comments? And then we're actually able to see the themes that they were able to build, and then drill down within those themes. So when you see a credit union, we want to see a great loan score. People often go to credit unions for loans. So that's a really important thing for us to look to. And so the lessons learned here, again, it's the last mile. It's something where, the sentiment alone, I don't think is really going to get you everything you need. There's a difference between, man, I'm broke, which is definitely not a positive sentiment, but it doesn't relate to the credit union. And, I got stuck in the drive-through for 3 hours. Those are something that is directly correlated to the credit union. So we want to have something where sentiment plus this custom modeling on top really created the solution that they needed. But that out-of-the-box sentiment was able to get us right to the edge, and we just needed that last mile of AI. So it's where you can put these two things together and really see something positive. The other thing that we really learned out of this project is, for us, it's a hugely important thing to try and take into account the tribal knowledge of your team. I'm not an expert in credit unions. I don't think I ever will be. But there's certainly that marketing team that we were working with for the credit union. They know everything about that business. So we should be working and leveraging their skills to be able to understand what is, the topics that we're looking for. I think one of the things that we missed on our first pass of creating topics was drive-throughs. I never think about, when I think about a bank, I think about a drive-through. I use an app and that's about it. I don't think I've been to the bank in a long time. But, that's a huge thing for them, especially when you're talking about physical locations. So going to that team and really, incorporating the team that's doing this work and getting that tribal knowledge is so important. So then our last case is something that, this is the one where we're actually completely able to leverage something out of the box. So we're looking at a company that does direct sourcing. They want to be able to find and fill positions, so find the right group of people for a job. And if you've ever looked for a job or tried to hire somebody, you've probably seen a bad job description at some point. People go and they put these job descriptions together that are like, I'd like to hire a software developer, would help if you could use a computer. That's really great. It's maybe it finds what you need, but it's not going to entice anybody to come and apply for that job. And you're going to end up with candidates that aren't really a match because you didn't say, oh, I need them to be able to program Ruby on Rails. So we want to make sure that we're leveraging sort of that information, making a really good job description. So we leveraged existing technologies. We'll see that in the next page, that can clean up a job description really well. So the group's technologically advanced. They do a really good stuff using custom-built machine learning models. They've got a pretty robust, technology suite. But this is something that they, it was a problem they wanted to solve, but they don't want to take a huge amount of effort to solve this. They could go back to the client and say, please give me better job descriptions, or they could, if there's a quick solution, let's try it. So because this was used for out of the box, we didn't even need to use their internal data. We didn't have to have something that said good job description, bad job description. We were able to just leverage this out of the box. So if you jump forward, we've, again, we want to figure out how do we manage short descriptions, and then on the other side, long descriptions as well. Sometimes you want to summarize a job description. If you go and try and apply for a job and it's like 8 pages long, I'm definitely not going to read that. So what we did in this project is we actually utilized ChatGPT. So in the same way that you're doing when you're going and saying, hey, help me out in editing this letter or help me write an email, you know, we're able to leverage ChatGPT through an API. So the computer is able to access ChatGPT. Because they had no customization necessary, it's something where we were able to say, hey, as long as you can get it integrated in the front end, or as long as we can work with you to do that, it's going to be ready within a week. So an example of this, this is an actual job description I went on the internet and found for somebody who's looking for a customer service rep in Lafayette, Colorado. And I don't know, I don't know that I would apply for this job because it doesn't really give me a lot of detail. It doesn't, if you're not willing to write a full sentence, I don't know that this is the ideal working condition for me. So we were able to take this job description, feed this through OpenAI with a little bit of a prompt around it, and then it produced the revised job description on the right-hand side. So if you're somebody who's looking to fill resources, it's a really good use case, and I think it's something that even if you're not trying to do massive amounts of hiring and need to do this automated, it's definitely something you can use internally as well. If you're going to hire for a new position, ChatGPT may be able to help you out and just making that job description a little nicer. So the lessons learned here, don't rebuild. Bikes exist. We don't need to build a bicycle every day. We don't need a new LLM to help us understand exactly how to fix a job description. Out of the box, really, it's something to look to. If you can leverage that solution, it's definitely worth doing. And then minimizing user effort. One of the things that's really important is when you're looking at large language models, the prompt is really important. If you ask ChatGPT for something, it sometimes produces a great answer, it sometimes doesn't, and a lot of that can come down to the way you phrase the question. So rather than asking the end user to interact with ChatGPT, we were able to say, here's a little button that says what you're looking to do, and we can look and see that this is a really long one, let's summarize it. This is a really short one, let's augment it. But you can minimize that user effort by being smart about the code that's happening behind the scenes. I'll turn it back over to Chad.
Katie, happy to take it from here. Thank you for those case examples. I just want to summarize what you can take back to each of your teams on this to help put some of this to work for you. And that first step is going to be probably to come up with your first AI project. Brainstorm and then use that quantification. Take your best candidates, drill into your best candidates and say, these are the top 1, 2, or 3 things that we think we've got a real opportunity for. You've got a good source of truth for it. You've got realistic goals and you've got a plan. You know that you're going to prioritize it. You know what you're going to do with the result. And that's the point where you then say, great, now I need to talk to a group like NLP and I need to understand how do we actually put this to paper? How do we get a project off the ground? Which of these are feasible so that you can fully quantify what your cost to implement is going to be, what your benefit's going to be, what your timeline looks like. And with that, I'm going to turn it back over to Brian because I imagine we've got a couple of questions from the participants today.
That we do. I feel like I need to preface the first question to say we are not legal experts, but the question is, what are the legal ramifications here? There's stuff in the news about people getting sued, or I think there was an attorney that used ChatGPT to write closing arguments and they weren't accurate. What have you guys seen here as far as legal risk in using AI?
So I think from our side, there's really 2 directions for that. There's the legal risk of the actual output of the AI that you're using. So that's your lawyer who's writing closing arguments. I think understanding, are you able to use the results that were produced is a really important piece. But then the other side is understanding, what is really commercially viable. So if you look at some of the models that are out there, there's things that are coming out every day that are, here's the coolest new use of large language models. But if that was built on data that violates terms of service, or if that was built on data that's only available for public use and not for commercial use, that's where you can really sort of get into trouble spaces as well. So I think it's something where understanding the provenance of the data that's being used and understanding, is the model that I'm working with really sort of a viable option is really important. So I think there's definitely the ramifications on both sides, where you got to be careful about what you're using, make sure you're using everything to terms of service, and then just be smart about the resulting output and how you're using that as well.
I'll throw one more in there, Brian, and that's the use of AI for recording devices, things like applications like Otter that go to a meeting and record everything and transcribe it in a nice, neat way. And if there's a dispute and they go into discovery, and you might be handing meeting notes over that may not have been accurately transcribed to an opposing, counsel, and so there's a lot of things, it's a lot of times it's common sense. Would you bring a tape recorder into a meeting? And I think most people would not want that. Applications like this where it says, hey, you're being recorded. I know it, but there's things out there that are being used in a business setting that are absolutely AI driven. They're neat, they're slick. You just got to have that common sense in there.
Very good. Chad, anything
additional? I was just going to tack one more bit onto that and say, from an IT perspective, all of these things are really cool, and there are a lot of readily available public knowledge tools out there that leverage AI in various ways, and some of them are quote unquote free. But from an information security perspective, be aware, that's true in anything, if it's free, you're the product. So you have to help educate your users within your environment about information security and say, if you're sending your document, your proprietary document, to a third-party service that's online, that's free, and it's helping you properly phrase everything, if you aren't licensing that product, you actually don't have any control over what they're doing with that data. And you could be training the product, you could have data leaks going back into it. Commercial licensing, understanding the terms of use, understanding the privacy policies of the tools that your people are using is as important with AI as it is with anything else.
Got a couple of questions about the amount of data you need. So let's use this one. Is there any guideline or minimum requirement on how much data in terms of variables, history of the data, et cetera, do we need to be able to build a reliable model?
Katie,
I'll kick out.
It's a question that's really sort of interesting to tackle because it depends on the type of model that you're trying to build. If you're talking about those tabular models where we're making predictions based on historical data, we're greedy. So as much data as we can take, we always ask for. But it's something where, I think you're probably looking at, from a tabular standpoint, at about, 10,000 records is probably a start to being able to do some machine learning. But, when you're talking about things like image processing, you can have a lot less images, but you really need to understand how many times do you have a, what we call a positive case. So if you're trying to build a model that predicts, is this picture a dog, yes or no? It doesn't matter if you've got 20,000 images, if only one of them's a dog, then you're gonna have a really hard time doing that. So you wanna have a good mix of the positive cases, the dog cases, and the not dog cases. So with computer vision, you can get a much smaller set, but you really need to make sure that your labels are perfect. It's something where if the labels aren't great in there, you're gonna have a real struggle.
Very good. Question about how can I use AI to help with the RFI, RFP process? Any specific use cases there or any advice?
I'll take that one. So we have a customer, they're a very large electrical contractor here in the Southeast, and they brought us on to build a model to predict whether a project that they bid on would be profitable or not profitable, even before they put in the effort and burn the calories to start answering an RFP or an RFI. And we were able to build a pretty accurate model that, given all of the projects that they had had over the literally decades that this company was in business, we were able to build a pretty accurate model that gave them a go, no-go criteria. And now, also using some natural language processing, which is the reading of the RFI, you can get even better matches on the proposals that were submitted in the past. And so there's a real use case. Here you just make sure you have enough. Do you have enough data? And then also, can you tie it back where you bid on a project, you won the project, and then you performed on it? You're going to want to be able to connect all those dots, kind of when Chad was talking about connecting different data sets. Think of the data sets that go into an RFI, and whether you do or don't bid on it. Do you want to add anything else, Katie? You worked on that.
No, I think it's just a message of cleanliness on the data as well. Like Ted was saying, you have to be able to track things. And, if you have people that are sloppy at putting in data, sometimes you end up with circumstances where, we thought we found signal on something, but it was really a matter of people who didn't submit the full set of information. It turns out their projects are less profitable. So it's an important thing to know, but it's not really telling the full story. So having clean data or understanding what constitutes clean data is really important in that sort of circumstance.
Very good. Question about adoption. So if a company's going to make this investment, you've got a couple of folks that are going to make the investment to do this cool thing. How do you drive adoption across the organization?
So I think one of the things that's really, really important as far as driving adoption is including people in the process. I think when you're building something, especially on things that are a custom build, again, that tribal knowledge is really important in two aspects. The first is that we're getting the information from the folks that have essentially like tacit information that's not typically captured. We want to make sure that gets captured. But it's also something where if you're going through and you're doing this iteratively and you're showing people this is how we're building it, this is what it's doing. Yes, it understands you and it wants to do what you do. We're using you as the example of good. Then that's where, a human sort of builds trust in that. If you go and you say, hey, we built this model over here, we just throw it over the fence. That's when I think you can really struggle because people don't understand it. It's scary at first. And, if you just throw it over the fence, people are going to think, oh, you're just trying to take my job. And it's really not the case of what AI is trying to do in a lot of these cases.
I'm going to take that question beyond AI. How many of you have purchased the latest, greatest, shiny whiz-bang software, subscribed to it, deployed it within your organization, and then realized 6 months later no one's using it? AI can be exactly the same way. The goal can't be we're going to use AI. The goal to the individual person on your team has to be, how's this going to make my job easier? How am I going to be able to perform better with less effort because of this? The inputs that the system needs, how naturally do they already fit into my existing workflow? Or do I now have to go to 3 different entry forms just to feed the AI? I'm not going to do that. The AI is now going to get garbage input. So the closer it can be to what's real and on the ground of the people that are participating as inputs and flows and quality control and output users of the system, just like any other software, that's how you drive adoption. You're speaking emotionally to the people that are working with it, and you're making their lives easier, and they're able to produce more, and they're proud of it.
Good. Probably have time for 2 more. We'll see how long the next answer is. We've got a couple of questions about false positives. I'm just curious, what's the average correct predictability percentage of a model? In other words, what percentage of false positives or true negatives are considered okay?
So that is a super loaded question, because I think it really, there's a couple cases where you want to sort of track things. The first is understanding what's the cost of a false positive versus a false negative. There's cases where I want to be 100% sure that I'm correct before I do this. If I'm sending personal information as a result of this prediction, a false positive is an absolute nightmare. But if I'm doing something like a drug test where I want to make sure, or a test for a disease, I want to make sure that I'm not missing any negatives or any positives. I'm willing to take the risk on a few more false positives. So it's something where you really need to weigh out those two things and figure out what is sort of the right ratio for you. But as far as understanding what's an appropriate level of accuracy, I think you really have to look at what could a human do. You know, I think when you talk about these models, like, you know, predicting, is there a dog in this picture? People are really good at that. We're really good at looking at a picture and going, yeah, there's a dog. And usually an AI is going to do a pretty good job too. So we're going to look at that and see, you know, yeah, we're going to get a 99% accuracy there. If I'm looking at, you know, a medical scenario where I'm trying to predict an outcome for a patient, and, you know, if I went to a doctor and said, you know, I've got a 73-year-old male with these conditions, are they going to survive? Yes or no? You can't see them, you can't examine them. Are they going to survive? I'm not going to expect that doctor to be 99% accurate. You know, I think we need to, you know, sort of have the same expectations for your machine learning model. So in that case, it might be 80% accurate. So it's something where, you know, you're not going to want to use it to say, do we put somebody on hospice, yes or no? But you want to use it as an input. It is valuable tool. But, you know, you have to expect, you know, from that model, is it something, how would I expect a human to perform if I gave them the same amount of information?
A question about Microsoft Copilot. Chad, I know you mentioned it during your piece. What's the expectation for Microsoft Copilot coming out? What's the use case there?
So if you think about what ChatGPT does, and I'm going to use that as a baseline, you can ask it a general question and it will give you a general answer back on that topic. Imagine if ChatGPT in the Microsoft security world had access to your business knowledge, structured and semi-structured, that's already stored in your email box, your Teams chats, your SharePoint, your OneDrive. Imagine if that information was now available to that same type of engine, to where it can draw correlations from your calendar, from your correspondence, from your conversations, from your business terminology, from elements that appear within your own business documents and within your own business spreadsheets. And now you can start posing questions saying, I need to compose a message for this, and I need to talk about these things, and it can go through your existing structured and semi-structured knowledge that's specific to your business and give you a much more relevant, tailored output. Copilot, some of the previews for Copilot have also suggested that Copilot can suggest predictive actions. Right now, you're probably all using Microsoft Outlook for your email, and you know the difference between your focused inbox and your full view inbox. Well, focused inbox has been applying general rules about what you read and what you don't take action on, and it's bringing the important things to the forefront. Copilot takes it one step further, and I've seen demonstrations where it'll say, would you like to reply back with this? Or they're asking for this information. This information appears to be sourced from these things in your prior correspondence. Would you like to include that in your result? Here's a pre-composed result. Please edit it, hit send when you're good to go. So those are the types of things that Microsoft is envisioning for launch. Where it's going to go from there, I imagine it's only going to get deeper as it understands more and more of the lexicon of the business information that's already stored in the Microsoft 365 platform.
Deal. Well, thank you all. We are out of time. Chad, if you could flip to the next slide.
Sure.
For me. Coming up on October 18th, we will have our next webinar in the series with the FBI. Those of you that joined us for the Lunch and Learn series that we did last year, Agent will be joining us to talk about the latest threats that are out there. Chad will also be joining to talk about some of the things that we're seeing on our end. So would love for you all to join us again.